Hello everyone. In this video, we will learn how having an equiprobable sample space will help us to compute probabilities of different events. Let us start with a small discussion on this. So let's fix an equiprobable sample space. Say we have a sample point A1, A2 up to AN. And we know that this is an equiprobable sample space. What can we say about the probabilities of these guys? Being equiprobable means that the probability of A1 is equal to probability of A2, and this will go up to probability of AN. On the other hand, we know that probability of S must be equal to 1. That means that the sums of the probabilities of each one of these sample points, or all of them, you add them, you get 1. But since all of them are equal, let's call that one that probability, that number probability x. So this will mean that x plus x, how many times n times you add x to itself, you get equal to 1. That means that n times x is equal to 1. That means that x is equal to 1 over n. So in other words, probability of every one of these sample points is going to be 1 over n. Or other way of saying that, this is 1 over n of the whole sample space. But this doesn't stop here. Now, if E subset of S is an event, well, it could be different things. But now if you're looking for, let's say, such as, I pick A1 up to AK. Yes, then probability of event E, well, here I have A1, so probability of A1 plus probability of A2 up to probability of AK. But we know that all these guys have probability 1 over n. So I have 1 over n there, 1 over n there, up to 1 over n. How many times? N times. Oh, sorry, k times. There were only k of these guys. So that means that when you add these guys, you will get k over n. That's the second fact that you can easily see here. So this was the first one. And as a result of that, we have probability of an event subset of an equiprobable sample space is equal to this. K is number of elements of E, so this will be n of E over n of S. So this is when E is subset of S and S is equiprobable. So that is where we have the second and important formula. Why this is important? Because if you're trying to find probability of something, you try to make it an event, that event as an event of an equiprobable sample space, and then you're just going to deal with two counting problem, one counting of the number of elements of S, and the second one counting the elements of E, and then divide it and you will get that number. Let's see this in some examples. A single die is tossed. What is the probability that even number comes up? So here E is even number comes up. Yes. as we discussed before, it's good to have an equiprobable sample space here. So we learned this, well, just by intuition at least, that 1, 2, 3, 4, 5, and 6 is an equiprobable sample space for our experiment here. And the subset E is basically 2, 4, 6 is an event inside that. So when you have an event inside an equiprobable sample space, finding probability of that event is easy. You just need to count how many elements E has and how many elements S has, and then divide them. So here there are 3 over 6, which is half. Okay. Or other example here will be 2 dice are rolled, and then what is the probability that sum is 7? So event that we're looking for, its probability is the sum of the numbers is 7. And what is the equiprobable sample space for this one? Remember that we did this one before. So list all the outcomes. Due to some symmetries in the die, this will be clear that this is an equiprobable sample space. Now, E can be written as or is a subset of S. Why? Well, I can just go ahead and list all the outcomes which add up or whose numbers will add up to 7. For example, I can have 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. And since this is an event inside an equiprobable sample space, finding probability of that is not difficult. You just need to count how many elements E has and divide it by how many elements S has. So here 1, 2, 3, 4, 5, 6 over 36 in general. There are 6 possibilities for the first one and then second one. So this will give us 1 over 6. The probability that the sum is 7 is 1 over 6. Let's do another example. Here, a letter is randomly chosen from the letters of the word assessment. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters in this word. And we are trying to find probability of E is chosen and or M is chosen. Here, the first thing that comes to mind is that, okay, the sample space, we can see, okay, what are the letters here, possible letters, A, S, E, M, N, and T. But when you look at this sample space, the sample point S is more likely to be chosen or to occur than the other ones, because there are 4 S's there. It's more probable that we will choose one of the S's than just only one N. So that means that this is not an equiprobable sample space. So we cannot use the formula above. You cannot just say, okay, there's 1 out of 1, 2, 3, 4, 5, 6. The chance that you get S is not 1 over 6. So this cannot be used. we have to come up with another idea or another way of making an equiprobable sample space. Here, one way to do this is that my sample space can be the number of the letter chosen from the word. So I either choose the first letter or second letter, third one or fourth one, and this will go up to 10th one. Yes. So if we do that, then the chance that the first guy is chosen, no, I don't know what is that letter. It doesn't matter now. Each one is going to have the same probability. So this is an equiprobable sample space. Now, the event that E is chosen, we can write it as an event in S1. E is chosen means that either the fourth or the eighth letter are chosen. So I can write the first letter or the eighth letter. And that means that I can go ahead and find probability of E just by counting how many elements E has and dividing it by the number of elements of S. That will give me 2/10, which is 1/5. How about M is chosen as an event of S? I see that there's one possibility, and that means that I choose seventh letter there. Yes. And since S is equiprobable, the probability that M is chosen, so maybe I should write it more carefully there. This will be N over this guy, the number of elements of that event, over N of S, which is 1/10. And the last one is S is chosen. S is chosen will go either the second one, third one, fifth one, or sixth one are chosen. Yes, so we have 4 letter S, second, third, fifth, and sixth. So that means the probability of S is chosen is equal to count how many elements this event has. There are 4. The total number is 10, so that will give me 2/5. And now I can go back and show you why we didn't have the first given sample space is not an equiprobable sample, because this guy has probability 4/10. Now with more numbers here, this has 2/10. This guy has 1/10. This has another 1/10. This is 1/10. And yes, A also has 1/10. As you can see, well, they have different probabilities, and that's again another confirmation that what we started with was not an equiprobable sample space. But when we fixed the equiprobable sample space, everything was easy to complete or calculate.